Hello, everybody, and welcome back to Math Television with Mr. BB, your host here. How you doing? Okay, we are looking at today something called the tangent ratio. We're starting trigonometry, and to do that, you'll notice I have a new program open called GeoGebra. And the great thing about GeoGebra is that it is a free program that you can download yourself, or you can run it off the internet either way, and you can do all sorts of cool stuff with geometry, obviously, and maybe even algebra, hence the name, I guess. Anyways, there is a link to this website that you will find on our homework page today. I'll leave it up there, and if you go to the download page, you'll see you have all these different download options, and I chose the offline installer so that I can use it even without an internet connection, which I suggest you do because you know what our internet connection is like at school, even when it is working. Okay, so what I'm going to do is I'm going to quickly draw just a triangle for us to start trigonometry, and just to kind of show how the program works a little bit as well. Okay, there's one segment there, and I want to create a right triangle, so I'm going to do a perpendicular line, and I'll just do that for you right now. And then I won't show you anything else but the program. I'll let you kind of do it on your own a little bit later. Oh, sorry, I want to do a perpendicular line, so I click on this, and I click on that, and there's my perpendicular line, and I'm just going to finish making my triangle here now. Okay, so I did a little bit of magic while I paused the video here. There's my triangle all set up. You'll see that I've labeled the sides with their lengths, and this is a 90-degree angle here showing you that, and this is the angle on this small angle over there. And what's really cool with this program is I can change the length of that side, thereby changing the angle as well, you'll notice. Okay, or if I want to make that other side short, I can click over here, okay, and notice that it's still a 90-degree triangle, and that's still 952 degrees, okay. So all those things just kind of change automatically, all right. And I'm going to pick something, so I have there 3 decimal places on all my numbers. And I just want to show you something fairly significant. So I just want to draw your attention right now to this side right here, this 4.408 centimeters, this is, okay? And this angle here is one that is going to be the angle of interest for now, okay? With trigonometry, what we're dealing with is always a right angle triangle. This will always be 90 degrees for you guys in grade 10, okay? And then this other angle here is what I'm going to be looking at right now. I could be looking at this angle up here, but I'm not. Right now I want to focus on this angle, and the reason why is because this angle over here is the opposite side to that angle. You can sort of imagine like this is like a little eyeball. Like there's like the eyelid here, there's the bottom eyelid there, and this is like the little eyeball, and it's kind of looking across the distance to this opposite side. So we call this the opposite side, and it is 4.408. And if you look here at the side that is next to the angle, this is the side that is not the hypotenuse. We have the opposite side, and this side that is next to our angle that is not the hypotenuse, we call it the adjacent side. Okay, and so if you take a look at the opposite side and the adjacent side, they have a certain relationship that may not be totally evident. Let me kind of show you how these things are related. Okay, so forgive me for switching programs here, but I just wanted to be able to write and show stuff to you. So this is the same. Here's this triangle there. I just transferred all of the dimensions to my drawing here. Okay, so there's my opposite side right here, and this is my adjacent side. Again, we're talking about this angle right here. This is my angle, 23.952 degrees. Okay, and therefore, if you look straight across from that angle, this is my opposite side, and the one that is next to it is the adjacent side. This, of course, is the hypotenuse, and we don't want to get that confused with the other side. And if you look specifically at the ratio of the opposite over the adjacent side, you'll notice I got a value of 0.444. And if you have your calculator with you, you can actually figure out that ratio without knowing the side length. So on your calculator right now, if you have time, type in 23, there you go, 0.952, and then hit the tan button, or go tan button first, then 20.952, and see what you get. I'm going to do it right now. Ready? Boom! Look at that, 0.444, the same thing. Okay, let's look at another example here and explore this a little bit more here.